So I forgot to teach you quadratic inequalities. Now I'm going to teach you this again. Towards the end of year 11, we'll go over them. We'll make sure that you remember them and that you can do them. They are much easier to understand when you've done graphs, and you haven't done graphs. So they're fairly meaningless now, and you're mostly going to have to take me at my word. But you'll see when we do graphs that they make a great deal more sense. They are considered to be very difficult, and you don't have to master them fully now. If you can manage these homework questions, that'd be great. What I think you should do is for each of these examples, I am going to put the new example up, and then you should pause the video, try it yourself, then watch the answer, and then do it like that. Obviously, you need to put most of these inside your notes, if not all of these inside your notes. And please just try each question yourself, then pause the video, at least pause the video, try the question, show the video again, see how to do it, and try the next one, like that the whole way through. Okay, so this first one, it's quadratic, it's got an x squared, and obviously, well, not obviously, but what we usually end up doing is we usually end up factorizing. So we need factors of 7 that add up to positive 6. So the first thing you do is you factorize, and you make sure that you factorize correctly, because if your factorization is wrong, everything else is wrong, okay? Now, these numbers that you would get, if it was an equation and you carried on further, you'd get x is equal to minus 7, and you'd get x is equal to 1, right? It would be better if you didn't write that down. But what would be nice if you wrote down was a little number line, and you put your answers on it. There's the 1, there's the minus 7, okay? Now, there's another method for working out which area of the graph we want when you've done graphs. But for now, you're going to try and understand that these are the limits where the whole expression changes from positive to negative and vice versa. In other words, I'm looking at this whole thing here, the whole thing, and I'm saying that it has to be greater than 0. So I'm saying that whole thing has to be positive, right? If I take a value in the middle here, like any value from this section over here, like 0, and I put it inside here, so I go 0 plus 7, and then 0 minus 1. This whole thing has to be positive. When I've multiplied them out, that's negative 7. So this is not the right area. So this is an area that gives us something negative, right? If I try a value from here, I will find out whether that area is positive or negative. So say I try 2. 2's on that side of 1, and I go 2 plus 7 and 2 minus 1. Notice I'm trying to work out whether this whole thing here is positive or negative. I get 9, and I get times by minus 1, so at least times by positive 1, so that's 9, so that's positive. So that is part of the area that we want, right? That area starts here. This one says it says the thing is greater than or equal to, so it's allowed to be equal as well, right? If x was equal to 1, then you'd have 1 minus 1, that would be 0, and it'd be equal to that. So we want this area here. We want it to be equal to 1, and we want it to be greater than 1. This area over here, they always alternate. So, well, they don't always, but they almost always alternate. And so this one, I can pretty much guarantee is a positive area. But let's try it out. We'll take any number from this side, right? It starts at negative 7. Negative 7 will give us 0. Negative 7 plus 7 is equal to 0. 0 is allowed. It says it can be greater than or equal to 0. So we want to have this as part of our answer, and we're going to try with negative 8. So if I go negative 8 plus 7, and I go negative 8 minus 1, then I'm going to have negative 1 times by negative 9, which is positive 9. So that area is positive. So our answer is x is greater than or equal to 1, or x is smaller than or equal to negative 7. Please note that they're written as two separate inequalities. You don't try and blend this together. There's no way that you can write this with an x and a 1 and a negative 7 and it could be true. There's no way. Now you're saying x is smaller than 1, which is not, it's greater than 1, right? So don't try and write it as a single one. So what you need to understand, you're going to do what you've always done. you're going to make sure that you have a 0 here. It's a quadratic inequality. You're going to make sure, first and foremost, that you have a 0, right? Then you're going to factorize. Then these are our limits where the expression changes from being positive to negative. And so we just need to test out and see where which side is positive and which side is negative, and they always alternate. Here's a second example. So if you feel confident, try this one by yourself, pause the video, and then have a look. Otherwise, just watch. So obviously, I am going to move that across and make it smaller than 0. Then I'm going to have to factorize it. I need factors of 10, so probably 2 and 5, and factors of -3. I'll say -3 and +1. I want something big, so that 5 times that is -15. 2 times 1 is +2. That's -13. That's correct. Okay? So factorizing, same as usual. Going to put my 2x there, my 5x there. Want to multiply the 5 by the -3, so I put it in the other bracket. Before you carry on, you definitely want to check that you've got the right thing. So you want to quickly say, is that 10x squared? Then I've got plus 2x minus 15x minus 3. Because if you factorized wrong, everything's wrong. If you were going to solve this, now this is definitely not equal to these. So these things, they're not equal to 0. So we're going to go and solve it somewhere else out the way. If we were going to solve it, we would say x is equal to 1.5. And we would say x is equal to -1/5, right? So those are our limits that we're going to use to work out where our graph is positive and negative. When x is equal to -1/5, this whole expression here is 0, because it means this bracket here is 0. So of course the whole expression is 0. When x is equal to 1.5, the whole expression is 0, because now this bracket is 0. We don't want it to be equal to 0, so those two are not going to be part of our answers. I'm just checking what I did here. Yes, I did put greater than or smaller than. Good. So those two are not going to be part of our answer. That's where our answers are going to start. Now this time, we're saying that we want all of this stuff here to be negative. It's smaller than 0, right? So we want it to be negative. So we're looking for the negative bit. Now the negative bit is very, very often in the middle. Not always, but often. So if we were going to guess, we would guess that our solution was this area over here. We're going to check. We're going to take any value in there. 0 is far and away the easiest value to take if it's not one of the answers. Then I've got 2 times 0 minus 3, and I've got 5 times 0 plus 1. So that's minus 3 times by positive 1, which is -3. So this section over here is negative. It's the section we want. If you take any value and check here, it will be positive. If you take any value here and check there, it will be positive, I guarantee, right? So our solution is x is smaller than 1.5 and x is greater than -1/5. Not equal to, because this is not equal to. Right? It's not equal to, so no equal signs there. And this is one piece on the number line. You show it as one piece in the inequality, and everything will be right. Okay. So, next one. Again, if you're feeling confident, pause now and try yourself. So this is 5x squared minus 125. Whoa, what have I done? Minus 125. Is smaller than or equal to 0. So always solve for 0. Always, always, always. Take out the 5. I've got x squared minus 25 is smaller than or equal to 0. I can divide both sides by 5. 5 is definitely not an answer. And I can factorize using difference between two squares. So of course you factorize, same way as usual, no differences. Our two answers are -5 and +5. This one is equal to, so we're going to actually use them as part of our answers. And now we want the piece that is negative. It's saying this whole thing here is smaller than or equal to 0. So in other words, they're saying it's negative. It will probably be the middle section, but it isn't always. Seriously, you don't want to rely on that. You want to actually use your brain. I'm going to go for 0 again, because 0 is nicely over here. And if I go 0 plus 5, 0 minus 5, that's -25. Definitely negative. That's our answer. X is between 5 and -5, but this time it's also equal to both of them, because it's smaller than or equal to 5. And obviously, when x is equal to 5, then that's equal to 0. I hope that's okay. Next one. Same thing as usual. Everything's over already. That's great. I'm going to take out the 6x, and I'm going to have 3x plus... Okay, I'm being weird. I'm going to have 2x. No, I'm not going to have any x's. I'm being very weird indeed. Sorry about that. I'm going to have x plus 3, right? Check that you factorize properly so that if you do weird things, everything is going to be wrong. Our limits are now 0 from this one, right? That one, that's 6x is equal to 0. That's how we'd work it out. And then, of course, minus 3 from that one. So those are our limits. This one is greater than, so we're going to have open circles here. It's not going to be equal to that. And we are looking for where it is positive. It's saying the whole thing, by the time you times it together and you get an answer, it must be positive. I can't use 0 this time. I'm going to check by using 1. 1 will be nice and easy to use. It's over there. So I'm looking to see if this piece is positive. That means 6 times 1, 1 plus 3. So that's 6 times 4. It's 24. It's very positive indeed. That piece will be positive. That one will be negative. That one will be positive. We want all the positive pieces. So we want that piece. And we want this piece here. So x is smaller than negative 3, or x is greater than 0. Two separate pieces, that's your answer. Please watch these videos as many times as it takes to sink in. If you had a negative quadratic, you would do the same thing that you would always do. You would take out the negative. Now, I wouldn't drop that negative if I were you, because if you do, you're going to have to turn the sign. Actually, I'll show you both ways. So we have two choices. At this stage, we can do it this way, or we can do it this way. Okay. If we decide to just factorize, I need factors of 20 that are going to add up to negative 1. So that's going to be x minus 5 and x plus 4, and the whole thing has to be greater than 0. So my limits are 5 and negative 4, right? I don't want it to be equal to it. It's going to be, and I want this whole thing here, the whole thing, including that negative sign, must be positive, must be greater than 0. So I'm going to try it with 0. I'm going to put a 0 here and a 0 there. Then I'll have minus 5 times by 4, which means that this, where the 0 is, right, is positive. So now the middle piece is positive. The middle piece is what we want. We want x is smaller than 5 and x is greater than negative 4. If you did it by the other method, if you decided, okay, what I'm going to do is I'm going to divide both sides by negative 1, right? So now that's positive. Then I need to turn the sign. Do you see that? I need to turn the sign. So if I get rid of this negative, I have to turn the sign, right? Now we would do the same thing. I'd have negative 4. I'd have 5. Now I want the negative bit. If I go and I test this out, the negative bit is inside here, and x is between 5 and negative 4. Okay, so if you decide to divide by a negative, you need to turn the sign as usual, or otherwise you can just carry on factorizing and leave it as it is, and then the middle piece is going to be positive. Learning that the middle piece is positive, is negative usually does not work well, because there will come a time where you're going to have something that has more than one piece. And I just wanted to show you that this works always. These are our limits. Our limits are x is negative 3 from the first bracket, x is 1 from the second bracket, and x is 4 from the middle bracket. Okay, so the last bracket, this one, makes it x is 1, this one is x is 4, and that is x is negative 3. The 5 makes no difference. We don't want any equals, so we can put dots on them immediately. Now we want some of those sections. They definitely alternate. But now you can't just glance at it and see which one the positive or negative section is. So you are going to test. Again, I would test with 0. 0 is the easiest one to test with. That means I'm testing the region between 1 and negative 3. If I have 0, then that's 3, that's negative 4, and that's negative 1, right? So your answer is positive. So this piece here is positive. Right? We don't want the positive bit, we want the whole thing to be negative. it says over here, so that's positive. It says over here we want everything that's smaller than 0, right? Not equal to, but smaller than 0, right? So that piece is positive, this piece is negative, this piece is negative, and this piece is positive. They alternate, right? So x is smaller than 4, but greater than 1, or x is smaller than negative 3. Okay, you want this section here, that's the negative section, and you want this section here, that's the negative section. Last one. If you had something with division, which you definitely are not going to have anytime soon, but in the future, same thing. These are your limits, -9 and 2. Okay, I know that this is a bit different, but and it doesn't matter if you take this last example in at all. I just wanted to show you something. If you get it, great. If you don't get it, doesn't matter. This one is solid. It can be equal to -9 because it says the whole thing can equal 0. And if x is -9 over there, then obviously the whole thing is 0. However, it cannot be equal to 2 because if x is equal to 2, I'm just going to erase that. If x is equal to 2, then this becomes undefined because 2 minus 2 is 0. So it doesn't matter that it says greater than or equal to, you are going to have to use not equal to 2. And again, you're just going to see, you want the whole thing to be positive. It says to you, this whole thing here must be bigger than 0, right? So I'm going to test with 0 there and see if that's positive or negative. So if I use 0, I've got positive 9 over negative 2. That middle piece is negative, so I want this piece and I want this piece. So x is greater than 2, or x is smaller than or equal to -9. If you didn't get this completely, don't panic. This is not the end of the world. Please just try the 5 questions, have another look at the videos, and when we do graphs, this is going to be much clearer.